Okay, so here we have our last example looking at areas of two-dimensional regions. And for this one, it's going to be quite a bit different actually. You'll notice right away, even though we have here y as a function of x, we're given here x as a function of y. Now it is a parabola, x is a function of y, however it's opening towards the right. Okay, this is our parabola right here. And we're looking at the area bounded between these two curves. So that's the area of this red region. Now, there's going to be something about this that makes it different. So let's just suppose that we do here vertical rectangles, very much like we were doing in the last example. So here, suppose that I do my rectangle right here. No issue. Okay, I have my base width is delta x, and I can clearly see what my upper function is going to be and what my lower function is going to be. Now, is that the case everywhere? Okay, so what if I had instead drawn my rectangle over here? Okay, so now my rectangle, I still have the base width is delta x. Okay, but when I look at it, my upper function is still this parabola, but what is my lower function? Okay, my lower function actually still seems to be the parabola, and this is the case, okay, but it's a little bit weird only because we have here x as a function of y. You'll notice that if we choose to do these vertical rectangles like this, okay, we're working with delta x, and working with delta x means that our integral will be with respect to x. All of our functions should be in terms of x, and we don't actually have that. Okay, what we have instead right here is x as a function of y. So this is a little bit of a problem, and what we're going to do to get around that, and to get around the fact that we sort of have these two different lower functions, they sort of swap exactly at this point, is that we're not going to be doing vertical rectangles at all. Okay, what we're going to be doing instead is horizontal rectangles. And this may seem a little bit odd at first, okay? However, if I draw here a horizontal rectangle, then you'll notice only a couple things really change. Instead of having my base width be delta x, my base width will now be delta y. And let's suppose that our height, we interpret it to be the distance from here all the way to here. Then it's going to be the difference between those y values. Sorry, not the difference between the y values, it's going to be the difference between the x values. And rather than being upper minus lower, which is what it was before, okay, because when we do it vertically, it's upper minus lower, okay, what we're doing now is going to be the right x value minus the left x value, okay. So for this, let's sort of get this written down. So as just a note for now, okay, if we choose to integrate with respect to y, then our area function is going to change a little bit. Instead of being upper minus lower, it's going to be the right function minus the left function. And instead of integrating with respect to x, we are going to be integrating here with respect to y. Okay, so this is very much what we're looking at. Let's see how this works for this particular example. So our area will be the right function. The right function for us is the linear function x minus 1. Now here, this is where you're going to notice that you have to be a little bit careful. Okay, I can't just put in here x minus 1 as my right function. You'll notice that in a moment we're going to be integrating, and we're going to be integrating here with respect to y. I do not want to have variable here x and integrating with respect to y. So we have to set this up a little bit nicer. We have to be a little bit more smart with how we do it. You'll also notice that when I'm doing this distance, and we're talking about right minus left, it's really the right x value minus the left x value. So we need to actually take this and figure out what the x value is. Okay, we need to figure out what x is equal to in terms of y. So x is going to be equal to y plus 1. And that is what we're going to use. So the right function, x in terms of y, it's going to be y plus 1. And then I'm going to subtract the left function being this parabola, and you'll notice we already have it x in terms of y. So it's going to be minus 1/2 y squared minus 3. We integrate with respect to y. And then the last thing we have to do is figure out what to do here with our limits of integration. So on our region, what is the smallest y value that we are using? We are looking here at y equal to minus 2. Okay, we're taking the y value from that point, not the x value. And going up here, what is the largest y value that we are looking at? The largest y value is 4. So this integral is going to give us exactly our area. And you'll notice doing this one with respect to y is going to be easier for a few different reasons. One, right off the bat, is that we end up only needing to use one single integral here rather than two. If we had done it vertically with respect to x, then depending on whether we're doing it over here or over here, we're going to have different lower functions. We would have needed to do this with two separate integrals. Okay, so this one, this is going to work. That's going to give us our area. And if you actually calculate this, okay, which again I'm not going to do for now, we're just interested in setting up the integral. This is going to give us 18. Okay, and that's going to be the area of that two-dimensional region. Now, after seeing this example, you might be asking yourself, in the future, how do you know, or how should you know, whether you should be setting up your integrals with respect to x or with respect to y? Should you be doing them vertically or horizontally? And really, my answer for you is that I would strongly recommend, as practice, to do them both ways. Okay. And in doing so, not only will you get to practice some very difficult questions, but what you're going to learn is on your own that it's always going to be easier to do it one way versus the other. Okay, and you'll start to get a better and better feel for which one is easier and which one is more difficult. Now, that's my recommendation, but if you want some sort of tips right off the bat, let's take a look at what you should be considering when you are deciding whether to do your integrals with respect to x or with respect to y. You'll notice in this last example, okay, if we had chosen to do it with respect to x, okay, we would have had two different integrals because we would have been changing our lower function from here, the linear one, to here, part of the parabola. Okay, so if you notice that you're going to have to split it up into two different integrals, okay, if you do it one way, then check what will happen if you do it the other way. So if you have two integrals doing it vertically with respect to x, then maybe you want to check what will happen if you do it horizontally with respect to y. That's the first thing. The second thing, in this example, you'll notice here, this is a big hint. X is given to you in terms of y. Okay, and in order for you then to go and do the integral, if you had chosen to do this integral vertically with respect to x, you would have had to go and solve for y in terms of x. And actually, if you take into account this parabola right here, you're going to notice that that's going to be a little bit of a mess. You're going to end up actually with two different square root functions, a positive square root and a negative square root. Really, this will be your positive square root, this would be your negative square root, and it's doable. Okay, but you have to be very comfortable with what you're doing. Okay, and so that's definitely going to add a little bit of complexity to these questions if you had chosen to do it y in terms of x. So my second hint is just that if you're given here x in terms of y and you think it'll be easier not to have to solve for y, then leave it as is, okay, and deal with everything horizontally, okay, deal with x in terms of y. So hopefully that helps. What I would also recommend is go do the practice questions that I have put up, and also if you have any questions about any of these or any of the practice questions, come see me during office hours.